Earth orbits the Sun at 30 kilometers Celsius, so to break a garbage rocket launched from Earth, you need to be able to accelerate 30 kilometers Celsius in the opposite direction of its movement. Here's where it gets weird. The closer you are to the Sun, the harder it is to crash into it. Let me explain. The closer you are to the Sun, the faster your orbital velocity. Mercury orbits at a dizzying 48 kilometers an hour, while Pluto cruises at a cool 4.7 kilometers. The faster your orbital velocity, the more you'll need to decelerate to free fall into the Sun. That's why it is actually much more fuel efficient to fly to the outer solar system. Decelerate and free fall into the Sun from there. It's not inconceivable to accelerate a spacecraft. 30 kilometers as NASA's Parker Solar Probe accelerated, beyond 176 kilometers per second, making it the fastest man-made spacecraft ever. But this brings us back to the problem of fuel. To make this break and fall method work, you'd first have to launch your garbage payload into orbit with Earth, then launch the fuel for the journey into orbit once both pieces are orbiting Earth. You can fuel up your payload and accelerate it past Earth's orbit into orbit around the Sun. Then you'd have to use the remaining fuel to decelerate so that it free falls into the Sun. Why not launch both the payload and fuel at the same time? I hear you ask, well, the problem is, it's simply too much fuel for context. The Saturn V rocket that took man to the Moon needed 2 million liters of fuel just to leave Earth's orbit at 11.2 kilometers. A mission like this would require orders of magnitude more fuel. No modern rocket technology would even come close to being able to carry the amount needed for a journey like this. Okay, so scenario 1 is out. What other options have we got? Another way to decelerate in space is with a gravity assist. Usually when we talk about gravity assists, we are thinking of the kind that slingshot the Voyager probes into the outer solar system. However, gravity assists aren't only used to speed probes up, they can also slow them down if you were to approach a planet from behind, fly in front of it, and exit behind the planet like this. Your spacecraft loses energy while the planet gains energy. The Messenger and Baie-Colombo probes have both successfully used this gravitational assist technique to lose velocity and enter orbit around Mercury. The thing is, this takes a lot of time. Baie-Colombo was launched in 2018 and will only arrive into orbit around Mercury in 2020. Surprisingly, its path to get there is longer than the distance between Earth and Pluto. This is because to slow down enough, one gravitational assist won't do. In fact, Baie-Colombo needs 9 different gravity assists to slow down enough to orbit Mercury. Similarly, crashing our garbage into the Sun is all a game of carefully calculated orbital mechanics. If we don't slow down enough, we'll be stuck in the Sun's orbit. If we slow down too abruptly, we might get caught in another orbit we don't want to be in. Okay, you might be thinking, but Alex, this is all feasible. It's hard, but it's within the realm of possibility. So why don't we just do it possible? Yes, with the time effort risk. And technical challenges, probably not to be a cynic. But think about what could go wrong. First of all, we're proposing packing a bunch of nuclear waste biohazards and plastic onto a rocket and launching it from Earth. A launch failure or explosion could be disastrous to say the least. Even the world's most successful rocket, the Soi, has a 2 to 3% failure rate. I don't know about you, but when nuclear waste is at play, I don't like those odds. Even if the launch goes well, the project itself would be ridiculously expensive. So much so that no sane person would approve the budget. There are far too many other missions on the table that would bring so much more to science and humanity than a garbage disposal mission. And lastly, it would actually be easier, quicker, and cheaper, but still crazy expensive to shoot our garbage out of the solar system toward interstellar space. It would be less fuel-intensive since the acceleration required to escape the Sun's gravitational pull is 42.1 kilometers, just a 12.1 kilometers acceleration from is orbital speed. So there you have it. We don't shoot garbage into the sun because it's super hard, super risky, and super expensive. We're probably better off being more conscious about what we consume and how we recycle it. Thanks for watching. This video was in part made possible by all the astronauts on Patreon. If you think these videos add some educational value to the world and want to give them more stability, then the algorithm. You can become a paid member on Patreon to contribute towards their creation. When you join, you'll be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. Just sign up with the link in the description. Once again, a huge thank you from myself and the whole Asham team. Meanwhile, click the link to this playlist for more Astrom content. I'll see you next time.